Welcome students. In this lecture, let us look at the different supervised learning methodologies used for social media analytics. So whenever you talk about a learning process, it is nothing but training a system with already a known history of data. So this is the difference between the supervised learning and unsupervised learning. If you do not have a target vector or a target data, then you cannot process with the concept of supervised learning. So whenever you have a social media analytics application, the first thing you have to keep in your mind is, do I have a target vector for that? If yes, definitely you can go with the supervised learning. So how does it work? So you have a large amount of training data. And as I have already told, it is pre-trained or historical data. So you also have a target vector. This is called as data pair, or we call it as a label. You have the original data and also you have the label. Put together, we call it as a data pair. We now give it to the system and make sure that our data is stored in the system. This is an iterative process. All supervised learning category methods fall under iterative process. And once the iteration is done, we hope that the data is stored in the system. How do we find that the data is perfectly stored? It is based on an error value. Each iteration will give you some error. So depending upon the quantum of your error, if it is very high, then it still needs more iteration. If it is very less, then it needs less iteration. This is the process by which we make use of supervised learning algorithms. This is a small example where you can find the original input data and the target data. The class corresponds to the target data here, and the original input is nothing but the age, the job, the own house status, the credit rating, everything. So depending upon the number of input rows you have, that many number of elements will be there in your data. So we have different types of learning algorithms. So you can here look at the general process of the learning algorithms. You have the training phase, you have the testing phase. So what happens in training phase? As I told you, the original data and the data pair will be given to a learning algorithm. So far this will be only a computer program. So once it is learned, or we say that the training process is over, now this is called as a model. So this model is capable of doing the same application. Say, for example, classifying yes or no in the previous data history. So now we take a new data and check whether we are going to get the same possible output depending upon the patterns which are available in the system. If you are getting a wrong data or a wrong answer, then it indirectly indicates that the training process is not proper. So you have to go back and make sure that you train again. Additionally, the problem may not be on the training. Sometimes the problem may be also on the data. As you know, the social media data is full of heterogeneous data, so it is very complex. Probably you may need some amount of data pre-processing too, a data cleaning, a removal of data entry, a confusing data removal. So many types of data cleaning process or data pre-processing process are there. Maybe you can adopt some and then you can go for the training or the testing process. You have several algorithms. The simplest algorithm is the decision tree classification algorithm. So how do I classify the previous data which is given to me? So initially I convert this into two groups, probably positive one or negative one. So the threshold or the line should be in such a way that there will not be any misclassification of data. With a single division line, I have two groups. Now within a group, again I go for subdivision and this process will keep on continuing. Each time I will check whether the error is less or error is high. If the error is less, then it is indicating that my division of the groups are perfect. So I go on with the process till I reach the end stage of the tree structure. This completely forms a tree structure and each time we are taking a decision. That's why this methodology or this classifier is called as decision tree algorithm. This is one of the simplest algorithm which you can experiment for your social media analytics applications. Welcome, students. In this lecture, let us look at the different tree pruning and the overfitting methodologies. So, whenever we talk about decision tree, we are going to grow the tree to a larger extent. But what happens here is the tree size may become extremely very large, which may cause huge computational complexity to the users. So, how can we avoid that? So, one process to avoid that is called tree pruning, where we are going to cut some branches in the tree as we do in the real-time situations. So what happens here is we assume or we evaluate the different tree branches capabilities, or otherwise we can say we are going to measure the entropy or the gain of those specific branch, and if it is found less, then we can say we are going to remove that specific branch. This is called as tree pruning. Now, this will not affect the overall process of the system, because once the gain or the entropy is less, then probably the trees are not with that specific um, output or specific branch for their application. So this is the way how you can visualize the decision tree process. You can see first there is a two cut which is done in the first figure in a vertical direction. You can see many black dots and white dots on the other side. Then you will go for the second cut, where again you are going to classify the white dots and the black dots. And again with the black dots, again you are going to make a cut with which you can separate. So all the black dots as per this figure, or all the white dots, will come under one specific category. This can be mathematically evaluated also. We call it as Gini index or entropy. Any one of these performance measure can be used for the process. Now, how do you evaluate your classifier? There are many process by methods which we can evaluate the classifier. One among them is the performance measures such as classification accuracy, sensitivity, specificity. But again, the question here is you are choosing the training samples on your own for the training process. What happens if another set of training samples were chosen? Probably the results may change. To avoid this, we have a process called as cross-validation. So what happens is the entire training data set is, say for example, divided into four times. When it is divided into four times, at a time, one set of training sample is made use for the process. Then in the second, third, and the fourth time, the other samples are made use of for the process. So you will not face the biasing or the partiality given to the samples, but each time you will be given an idea how the samples were overloaded from one stage to another. Or we can say four times the experiments will be repeated and you will get the results four times, and the average of the results were chosen. These are some of the common performance measures, the true positive, false negative, true negative. These measures are identified from how successfully your data is classified. If we are expecting a positive result and your methodology also says true, then it is put under TP category. If the reverse, we say it is TN category. False positive or false negative are the two things where the contradictory happens during the prediction system. Once you calculate the TPT and FP, FN values, you can see the formulas precision recall, which is dependent on true positive. However, when you look at the other measures like the accuracy measures or the F measure, you can find out how performance varies over different levels of threshold in a time. So these are some formulas which are giving you answers in the form of numbers, but there are also graphical illustrations with which you can come to a result, which we call it as ROC curves. So it is a graph between the sensitivity and specificity, and each time when you are going to measure the threshold changes, so the sensitivity value changes, so the specificity and the sensitivity graph direction also will change. Based on how they are moving close to the y-axis, we are going to say that it is perfect. Welcome students. In this lecture, let us look at the concept of K nearest neighbor learning. As you know already, there are two types of learning procedures for social media analytics. One is called as the supervised learning and the other one is the unsupervised learning. Depending upon your requirement or depending upon your availability, you can go for any one of these techniques and do some analysis with the social media data. And you have to also keep in your mind the nature of the data is not homogeneous, it is going to be heterogeneous. However, the learning methodologies, they are predefined for any one of the type of the data only. So how can you tackle this problem? This is one of the serious challenges which the normal practitioners face. In spite of all these challenges, we can still adopt some learning methodologies which to some extent can give some good output for your applications. One such algorithm is our k nearest neighbor learning procedures. Already we have seen decision trees in the previous class. So in the decision tree, we saw how a tree-like structure is used to divide your entire data set into small pieces till you reach the end stage so that you can allot one data to a specific class. In the same way, we have also a concept called as neighbor. So the question is, who is my neighbor? You can take an image. Image consists of many pixels. Take a region of interest in the sense you can point to any one of the pixel. Now, who is the neighbor of the pixel? So now this answer depends on the user. You can have the immediate surrounding pixels as the neighbor, or if you feel no, my level 2 neighbor is also going to impact my output, then you can have them also as a neighbor. So the first thing you need to do is you have to choose the neighbor. Depending upon the level of neighbors, your results will vary. So generally speaking, we call it as k, a constant k. So the k is the one which the user has to choose. If you are choosing on a linear direction, the neighbors will vary even though you have a constant value of k. If you have the neighbors in the circular fashion, again, the pixels which you are going to take will change. It is not only on the value of the k, but it is also on the structural arrangement of the pixels. In terms of your image, which is a rectangular or a square shaped concept, we say the surrounding pixels n plus 1 in all the directions are going to be the neighbor. N plus 2 goes to the next level. So you can choose, you can give a value, and we have a training algorithm now. So now what I'm going to do is I am going to check how many pixels in my neighbor are, say for example, there are two categories, black and white, as given in the slide. Black. If totally 9 pixels are there, and if among them 6 pixels are black, then I say that probability of the region of interest pixel being black is very high. And remember, it is only probability, and there is no assurance that it is going to be definitely black. This is one of the drawback of k nearest neighbor algorithm. So likewise, you are going to proceed from the first point till the end point. When you consider a single pixel, then the chances of mistake is very high. But when you consider 65, 536 pixels, say for example, you can say that among 65, 536, the probability of getting a correct prediction is at least 70 to 80 percentage. Thereby, you can get the overall information from the social media data. So in spite of the several drawbacks, K nearest neighbor algorithm still stands as one of the best algorithm which a beginner can make use of for their real-time applications. You can see the training testing process. Again, as we have seen, the cross-validation process is also there. Depending on whether you have a larger size data or a smaller size data, you can choose a cross-validation, and based on that, you can evaluate the performance. Apart from that, you have the sensitivity, specificity, classification accuracy, and the ROC curve, which we have already seen in our previous video, are also useful for analyzing the social